Thanks everyone for joining. I'm glad to see everybody here. I've been talking about cybersecurity for probably coming up for 20 years, and it's one of those things where I think to try and keep it engaging but not spread tons of FUD, and people sort of looking at it going, well, this is not really relevant to me, it's been really hard. And I think you talk about it for so many years that you feel like you're talking about the same old thing over and over again. So I've thought, let's take a slightly different take on it. And view it from a different perspective without that kind of FUD and the concern of like all the scary things that are out there on the internet, but maybe just look at some of the things that I think are a bit weird and strange. And there's three kind of crucial insights that I'm hoping to impart my knowledge on you guys today. Mainly it's around kind of excessive exposure, and also the fact that you can't always control what things you're using and how secure those things are. So it's important to think about what you're using, but how do you manage that kind of expectation of securing the things that you don't control? And also, so much of what we have in place often when we're developing and building solutions is not actually necessary, and that often lands up leading to a situation where organizations have just a naturally insecure environment. So I've hopefully trying to sort of show you this in a slightly different viewpoint, about what's actually happening in the general threat landscape today. And it's no surprise what we see today in this viewpoint here, because we're seeing lots of ransomware, we're seeing lots of cloud-based attacks, we're seeing tons of phishing and social engineering still happening today, even though it's been around for many years. We're now seeing the advent of AI-powered attacks. I don't think we've yet seen the biggest threat around that just yet, but we are seeing attackers, threat actors using it and benefiting from it. There's an argument to say those that are using it in a more effective means than some of the things that you see out being quoted by people today are the ones that you should be worried about. So the people that are saying, hey, I've built this large language model that you can just change to get it to do whatever you want it to do are not the people that are doing the really scary stuff with AI. Those that are doing the scary stuff with AI are going to be the ones that you don't hear talking about it. And then also things like IoT attacks, and you'll see why I talk about that, because tons of stuff on the internet shouldn't be there. And that's why when I look at the internet, I'm doing this most of the time. When I'm researching what's out there, it just makes me think, why? Or I'm doing this, I'm going, I can't believe that's on the internet, but most of the time I'm doing this, because it's painful to see after all the years of education around cybersecurity, we're still seeing a lot of this stuff. So I've decided to give you some examples, and here's really why I'm making these reactions. The first of which is because there's a lot of stuff that's unnecessarily on the internet, such as management systems for pools. Like, why would anybody want to manage their pool from a remote location? There are things like, and this is all, by the way, accessed through just remote access tools that are unauthenticated. So if you just went to the internet and you know how to look for this stuff, you will find these sorts of things on the internet, just unauthenticated, open to see. And you can see here that somebody's just got a terminal open or a desktop open, and they're doing something with a schema design application, which makes me start to think, well, how much of this is intellectual property? Like, you know, is there access to somebody's really sensitive information and intellectual property? There's even things like grain silos, weirdly, that are on the internet, which allows you to manage those grain silos, which obviously has a massive impact when you think about it on, in general, when we saw obviously the Ukraine war and all that sort of starting to happen, the impact that it had on the supply of foods and goods and all those sorts of things were huge. So having access to these sorts of systems on the internet still feels very odd and very strange to me. And especially when you look at the operating system it's running a very, very, very old version of Windows by the looks of it. So again, there are certainly systems out there which I don't think people have really the interest or the need they think, to secure these systems. There are even things that are super bizarre, like you can actually find supermarket scales for some reason on the internet, which I don't even understand how that manages to get exposed on the internet when you're in a supermarket, but there you go. And they all feel fairly, I guess, why would you worry about those systems, right? I mean, I guess you could argue that these sorts of systems are out there for some reason, somebody's remote administering them. Why do we care when we're building these apps and tools and stuff that we build? So, some of the things that I think are slightly more concerning are the fact that many phones and devices can be found on the internet with debug mode enabled. So somebody at some point in time has decided they're going to develop an application, probably for their phone. They decided they're getting to app development, and now their phones, for some reason, are now internet connected as well. And you can literally interface with somebody's phone. In this case, it was actually somebody who put remote administration software on their phone, and you could access it. But in other scenarios, there are actually debug ports open on these systems, so you could actually interface with the phone's operating system if you really wanted to, which is, again, baffling. There are also scenarios where you can see people remotely administering some of these servers. So you can see in this case, somebody was actually creating a user account, which apparently had already existed on that system. And you can see they're logged in as a root user. So somebody connecting to this system could connect directly to it as a root user, and they could basically take full control of the system. There's no hacking involved necessarily. I mean, the way I treat hacking is that you have to exploit some vulnerability. In this scenario, you're just logging into a box from a remote location, much like anybody else would do. There are things like, interesting things like number plate recognition software that's available on the internet in China in this example. So you can see it actually picking up the number plates and obviously capturing lots of sensitive information in that regard, which could be interesting. Oh, my clicker seems to have worked. Oh, there we go. And then there are other systems where you think, well, I wonder why they're being picked up on the internet and are insecure. When you look at the amount of open ports that are on this particular system, there's no surprise that it's going to be fairly obvious that this system can be exploited. I don't even know what half those ports are going to be doing, but that's just ridiculous. There are also other things which seem a lot more concerning to me. There are things like building automation systems, which when you do enough digging using the information that's freely available and easy to get access to on the internet, you can get to the actual location of that system. Now, in this case, it looks like the manufacturer has actually got a test system that they're exposing to the internet, which, again, you could argue, what's the risk to that organization? A lot of the time, attackers are looking for one leverage point. So even if it's just a test system, they've got another layer of access into an organization, which they can use to leverage others. And I keep saying this to everybody, whether it's physically you're in a building or whether you're virtually in an environment that you've managed to exploit, often being inside of the organization itself gives you that credibility that allows people or makes people overlook you. So if you're already in a building, even if you don't have a lanyard on or you don't have any reason to be there, most of the time people just trust you because you're behind the security that's in place. And the same is true when you look at virtual environments or infrastructure. Once you're inside of the network, people aren't looking as closely as maybe they should be. This was a particularly interesting one because we've noticed that there was actually a till in what looked like a hotel. And we thought, I wonder if we could work out where the hotel is. And we managed to find the actual hotel where the till existed in. And so you can imagine the impact of having access to a till that's taking payments and how you could leverage that. And this was the particular hotel where the till was found to be at. Now, this one was a little bit more creepy. Forgive me because it's very weird. You can actually find this software, which is a software that helps people to manage their power in their homes. And this particular one actually had the name and address of the individual whose power management system in their building. And we took that and we managed to find the actual location on Google Maps for where that actual building was, which was where they had the control system. And then directly from that, we could then work out where they were through going to Facebook and obviously finding images of that particular person on Facebook. There are new malware which weirdly is actually trying to identify physical locations of people. And the way it does it is it's triangulating the Wi-Fi that the devices are connecting to. So the malware gets installed, and then it uses all the Wi-Fi access points these devices are connected to in order to do that physical triangulation, which is really a bit weird because normally, why would you need to know that information unless you were trying to track an individual if you're a hacker? Because ultimately, all you're trying to do is gain access to their systems or hold them to ransom or some other reason. There's no real need to know where their location is unless the malware is going after high-profile individuals or something similar to that. Because, of course, just knowing where they're located, if they're in the UK or in the US or wherever they are, is generally enough for most attackers, I would argue. So to be able to physically triangulate where they are as a location, just it seems like the next level of evolution, which just seems a bit weird. So how did I find all this information? Very, very straightforward. Like I say, there are tools out there that are readily available that you can buy subscriptions to, lifetime memberships for like $50 or something that will enable you to search for this sort of stuff. And all I literally did was just search for, give me all the unauthenticated remote access devices that you have out there. And I could have been going for days researching all this sort of stuff. And that's all just on the surface web. I'm not talking about anything outside of what you could access today now if you connected to your phones or with your laptops. Let's have a quick look at the dark web. Obviously, everyone thinks that the bad stuff happens on the dark web, but most of the bad stuff happens on the surface web, but why not dig into the dark web a little bit? Mostly what's happening on the dark web is that they're offering illegitimate services or ways in which to get access to identities or credit cards or those sorts of things. But there are tons of other activities that you can get access to on the internet through the dark web, which is ultimately you can buy access to hackers that will do work for you. So if you wanted them to hack somebody's Facebook account, you could. They are generally the sorts of things you see in the comments that somebody wants to find out about somebody else, but in theory they will argue that they can hack anything and they've got no morals, so they'll hack whatever you like. They're unethical, so it doesn't matter. Just tell me what you want and I'll hack it for you and I'll do it really cheap. Now, because of that reason, and also because these malware and ransomware writers are out there now trying to make money, you start to find that there are these groups, these ransomware gangs that are actually running their own websites, and they are essentially either showing off or they're exposing data for the purpose of making sure that they can try and, of course, capitalize on that. And it's shocking to see that this was only a few months ago that there was an attack or exposed data which they're showing examples of where they've stolen 142 gigs worth of an organization, and they explained exactly how they managed to do it. And then they have their own blogs. So these are all the sorts of organizations that these people have managed to compromise, and they're writing blogs about it, and then shipping off, of course, people to those locations to say, look, if you don't want us to expose any more data, you've got to pay us. So it's very easy to find this sort of information. There's not a lot of searching around. It's a bit more tricky than, of course, doing it on the surface web, but in theory, if you know where to go, you can find all these sites of all these ransomware gangs that are showing off what they're able to do, their capabilities. But what about cloud native? Now, because there was so much other stuff that we found that I just couldn't talk about, I thought we'd just put a quick video together, and also to help break up the talk a little bit. So I'm just going to run a quick video of like all the different things and the concept of why we think it's important to think about these exposed services on the internet.
Every day, sensitive data is unwittingly exposed on the internet. In business, it could be from the inner workings of industrial machinery or critical healthcare equipment, to more personal details, such as the sanctity of home addresses, even the intimacy of personal individual laptops and mobiles. All are ripe for invasion. As we voyage deeper into the digital age, it's our collective responsibility to safeguard the realms we've created. So, how do we secure the cloud native and tackle the dark side of the internet?
So I guess that's all the internet-related stuff, and the dark web, and like all those things are, all the way through from, like I say, mobile devices to desktops to IoT devices to industrial control systems. They're all available on the internet. So the next thing I thought we would do is to try and look at how new technologies and how innovation and things like the evolution of things like cloud-native technologies, how do they start to impact the security, right? And what is exposed? And I think a lot of the reasons why some of these technologies are exposed is just lack of knowledge, and a lot of it comes down to misconfiguration. There are, of course, vulnerable systems on the internet, and that's why you hear security professionals like myself continue to talk about patching and making sure you're managing and updating your patches. But when it comes down to things like Kubernetes, what you tend to find is there's a lot of it's exposed, and a lot of it's okay. Like, you can expose some of these services, and there is a necessity to do so. But when you start digging a bit deeper, you'll find that it's all over the place. So there's organizations all over the world that are trying these technologies, and maybe some of them are test environments, maybe some of them are production systems. Who knows, unless you speak to the specific organizations. But then you start to look at some of the things that are a bit more concerning, where people are either misunderstanding the concepts of some of these technologies and start to expose the things that you really need to worry about, because they start to expose sensitive information like the specific Kubernetes APIs, where you can get a lot of information. And to an attacker, sometimes what you see initially gives you that trigger, that idea, that concept of how you can take it to the next level, right? So sometimes a small piece of information can enable you to really capitalize on some of the other exposed services that you wouldn't necessarily know otherwise. So the more you reduce the amount of information that's exposed to the internet, the more likely you are to be able to reduce your attack surface area, which means that, one, you might not necessarily be picked up as a target, because there's two types of attackers. There are the opportunistic, which just scan the internet looking for these sorts of services, for APIs that are open, and then they'll take those APIs and then they'll use it to exploit those systems. There are then the more targeted attackers, where they'll be going after organizations and they'll be looking for ways into the organization, and they'll be very motivated to exploit these systems. The opportunity attackers will try the things they know that will work and then move on. The targeted will keep digging and digging and digging, which is why when you look at organizations' security posture and what they try to do, they will do scanning to identify the obvious things that they need to fix, and then they'll do a pen test because it will do more targeted attempts to exploit these systems, and that's why both these things are just as important as each other. But once you get a small amount of information, an attacker can start to leverage that. So once they see that, okay, there's Kubernetes available to me, and they look at the API, they then know, okay, they're trying to build a picture of what do these services do and how can I leverage and exploit those services. And what then happens, of course, off the back of that is, once attackers and hackers smell blood in the water, then you start to see more and more of these things start coming out. And then the examples here, the approach taken by the bad guys right now is that, and these are recent, right? I mean, I think they've all been within the most recent period of a year, is things like cryptojacking, which is fairly straightforward, right? It's a simple concept to understand. If you've got things like Kubernetes available to you, there's a good chance there's a ton of compute available to you underneath. And if you can stay stealthy, you can exploit the system in order to mine cryptocurrency, basically. So all of the most recent examples of malware that's being created, the idea is to find as many different services that are running Kubernetes out there as possible, exploit those services, and start using them to do cryptojacking or cryptocurrency mining. And there are some scenarios as well which are particularly interesting, because they're finding ways to use RBAC within Kubernetes to be able to persist accounts so they can stay within an environment for long periods of time. So you think you've solved a problem, but they've found a way to get around the technology in place. And that will often happen. You're also hearing a lot more, which is why I mentioned at the very beginning about a lot of unnecessary things that are available to an attacker once they're in. You're hearing more and more about what they call living off the land. And basically, the attackers are not using tools they've developed because they're easy to detect. They're easy to build detection rules to find these things because they're known to be malicious. They're going after and using the tools that are there ready for them. So on Windows, there's lots of things like PowerShell, which are really powerful, a really powerful tool to be able to run fairly sensitive sort of commands and all sorts of like high-profile activities on them, and they've got lots of functionality. So they're using that because then it's not obvious to the people that are monitoring these systems that anything malicious is going on. So as much as you can reduce the stuff that you're using in a system, you reduce the attack surface, right? And you reduce the chances of an attacker being able to exploit the systems that already exist in the platforms that are there available to them. So this is quite obviously a good example of where once an attacker gets a handle on how to utilize these technologies themselves, they'll start to evolve and use them. And a similar thing is happening, of course, with things like AI, where we're only seeing the early stages of how attackers are using it. And generally, at the moment, they're just using it to write really good phishing emails or help them to code better, because they're not naturally coders, typically. They're kind of self-taught developers ordinarily. And obviously, as we all know, most of the initial early-stage phishing campaigns that we saw were really bad grammar, bad spelling. Things like large language models can help that to be better. And now also with generative AI, you can start building really nice looking websites and code things for you. So the attackers are going to get better and better at that. Now, of course, poor security often hinders innovation, and there's a couple of reasons why I say that. One is there's a research that was done actually by Red Hat on the state of Kubernetes security, and they said that 53% of the vulnerabilities that are found out there at the moment are just misconfigurations in Kubernetes, and that's because innovation is moving so fast, people are forgetting about getting the basics right. And obviously, from a security perspective, we talk a lot about hardening, getting good configurations out at the gate so that when an attacker spots some of this stuff, they're not going to start realizing that they can really exploit your systems. A lot of people talk about the fact that security is going to slow down your application development. And normally that's because they have security concerns and they don't want to push a product out until it's fully ready to release, because they're now concerned that as soon as they put something on the internet, quite rightly, because as we've seen, there are tools and technologies out there just constantly scanning the internet for these sorts of things being exposed, that they don't want to put it out, and that will slow things down. There are also the major concerns that people have is once it's then in runtime, that's where their major concern is. So 57% are most worried about it once they're in runtime. I would argue that from my perspective, I would be more worrying about it much earlier on in the early stages of that rather than the latter. Is there a question? Yeah, go for it.
Can I just...
Oh yeah, go for it, yeah.
You bring the mic up.
Thanks. When you talk about security and developers, sorry, I'm having a sore throat, so maybe. So when you talk about security and developers, when developers are developing any kind of Kubernetes or any kind of systems, there's this particular framework of security alliances, and there's this government regulatory as well. When people are developing those software, they always keep it in mind because different companies have got different frameworks for security features. How could you say, like, how can we sell security in that sense where any particular company, X, Y, Z, say we have different frameworks. When we are developing our technology, we are keeping that in mind. So how can we counter-attack those questions?
Yeah, absolutely. So I think the question is more about, like, obviously, as you're developing systems, there's so many different frameworks you could use to implement security. How do you make sure that you're not wasting too much time, like focusing on the wrong things at the wrong times, and make sure the business understands what you're trying to do and trying to achieve? And yeah, I absolutely appreciate that. There's lots of scenarios where businesses are saying, well, should I be going down the route of looking at NIST, or should I look at some other security controls? Ultimately, the fundamentals that I find right now is that it's just getting the basics right, and most of the security frameworks will follow the same basic principles around things like least privileges, and also obviously patch management, and also making sure that you're applying the right hardening techniques to the systems that you've got in there. So ultimately, I think it just comes down to the basic principles of all of these standards are all very similar. Whichever one you pick, I think, is a sensible approach to pick at least one to follow, because it gives you a consistent route. And when you go to your auditors, or if you're going to your leadership team to say you've got a framework you're using, at least you've got something that you can get behind. And everyone else, like you say, can stay consistent with those things rather than everyone going on their own direction and deciding what's right for the business. But I will talk a bit about that in a moment as well, about what my kind of thought process is on it in general. Even if you don't choose to pick a specific security framework, there are things that you need to consider and approaches you can take. So I'll cover those in a sec. There are 4 C's, though, that I would say that are really important. There's cloud, cluster, container, and code. And to me, this means that, and this is why I say that people worry a lot about once it's in runtime. But in my view, it kind of starts earlier than that. If you get your images right and you do truly take a cloud-native approach to your systems, then security should be able to come along that journey with you. And I'm kind of getting ahead of myself, I guess, on my slides. But ultimately, technology and security and how they operate is that you need to code by design or secure it by design. And the same is true of compliance. A lot of people worry about compliance. And security and compliance sort of come hand in hand, sure. But there is 2 kind of core concepts. One is privacy by design, and the other one is secure by design. And if you're building into your images a concept of security, that's why I say, like, reduce the things that you have in your images. Sometimes you just don't need the things that are running in it. So if you really harden it down and you just focus on the things you absolutely need it to use, when you're building your applications and your systems, then it reduces the amount of stuff the attackers can use, like I say, living off the land or trying to exploit those things that are there. So that once you start to push things into and getting into runtime, then it's already secure at the very beginning. Obviously, image registries, I mentioned that as well, right? So you can't always rely on your third parties because sometimes you're using libraries and things that you're relying on the developers of that third-party library to secure. And there's been so many examples recently where it's not actually the vendor's part of the code which has been exploited. It's actually the third-party supplier's code. And you can't make them patch it. And you can't make them patch it within the same period of time that you want them to either. You can only focus on the SLAs they have available to you. So my advice is always that if you're looking at third-party solutions, look at the ones that are well-maintained, that are kept up to date regularly, and also look to your suppliers' contracts to make sure that if you have a real problem, you know they're going to deliver quickly to remediate that system. Or you're going to have to come up with very extensive mitigation strategies. Once you get into things like orchestration and stuff, it's really about limiting privileges, making sure that you're monitoring what's going on in your systems, the communication between all your devices, limiting your operating systems, like don't have like fat, bloated operating systems that you don't need, all of that functionality, and also making sure you're hardening them and you've got good monitoring. So once you start getting into runtime, you can monitor those hosts with confidence that you can look for suspicious or abnormal activities and still do all the kind of network checks and running regular checks on those systems. But you know that you've kind of hardened it earlier on so that once you get it into runtime, you're in a good place. Kelsey actually mentioned something which I really liked, and it's kind of to your point that you mentioned earlier in the question, which is that he's kind of has suggested that we're expecting too much of too many people. We're expecting everybody to become a security expert, and I agree with that. I don't think people should be expected to be security experts and have a great deal of knowledge on how malware works or how monitoring a security solution should work. But you certainly need the basic principles, but there should be enough people in a business to have a specialist knowledge of an area. So the way you can kind of look at this is that you've got this kind of shared context. So the CTO and the CISO will know what the risks are to the business, and they'll know what the scope is of the things you need to secure. But on the developer's side, on the network engineer's side, you have control over that stuff. So you need to work really closely together and collaborate on these things. But you shouldn't have just one reliance on one person being a security person. And also, you shouldn't expect everyone to be security experts because it's unrealistic. You've got other things that you need to be focusing your time on. So I think getting that working closely together and working on collaborative strategy, like having a framework or having some consistent strategy to cybersecurity, helps you to work closely together. And there is another concept which is fairly archaic, I would say, in comparison to like cloud-native technologies, but it's still a good example of how to think about cybersecurity. So if you think about this like in a cloud-native environment, you're not going to have a lot of this stuff like external firewalls necessarily, or routers or anything like that. But the concept still stands, which is that if you think about defense in depth, you're not relying on one security control to protect your systems. You've got multiple things. So if one thing fails, let's say somebody's attacking your application, and you've got an application firewall in place, it should be doing the job of stopping the bad traffic from getting to your application. But if that fails, knowing that your application is secure or that you're monitoring the application and it's secure by design will help give you the confidence that you know that if somebody gets past the firewall, at least the application is going to stand up to attack. And if they get past your users, at least you know they've got an endpoint protection or something in place that will help to protect them from getting malware. So thinking about defense in-depth strategy is crucial, and it comes at lots of different layers and lots of different systems, but it can be consolidated and made a lot easier. The other thing that is already being pushed by the NCSC, and this was just really recently, I mean, when I was doing some research for the talk, just on the 13th of April, actually, the NCSC actually came out to say that it's working with its allies in the Netherlands and Germany to try and push the idea of secure by design, which is the concept which I'm talking about essentially, which is that you've got to make sure you're securing your systems from the very early stages. So is there another question? Yeah, I've got a mic.
Sorry for being interrupted because I'm from the same industry. So maybe
no
I
worries.
have like a couple of questions.
Go for it.
So first things first, I just read it online that you guys are XDR.
We have XDR technology. We do loads of other stuff, but we do XDR as well, yeah.
All right, so this is about cloud native. So how do you compare yourself with Stellar Cyber? And what is your ranking in the Gartner Magic Quadrant? Is it there or is it not? Or how would you sell your product? Like, because I'm working as a solution architect, and we are looking forward for people who can be on our SaaS platform, and then we can work together afterwards. But we are in in conversations with this Stellar Cyber already, and we want to know. The only point me being here is, want to know more about your defense comm and what is the main differentiator.
Yeah.
You being an XDR and the other people being an XDR in the market.
Yeah, I mean, you should definitely, maybe we should have a catch-up afterwards and we can chat about it. But, I mean, look, from this perspective, from our perspective, the concept of, like, XDR and the idea of it was to try and help simplify it for organizations. And from our perspective, the reason why Gartner is not that interesting to us is because they're really focusing on the enterprise space, and we're not really looking at that. Our strategy is that we know that there are small businesses, startups, and organizations that really need to mature their security very quickly because they've got very little or they don't feel confident about their security, and they want to bring it to a high level. And the reason why XDR is really good at that is because it's not relying on you having lots of existing investments or existing security strategies. It's going to take you from zero to be able to do some sort of remediation, give you the peace of mind and ability to sleep easy at night without having to invest thousands and thousands and thousands of pounds. So it's kind of like a all-in-one sort of capability that gets people their maturity as quickly as they can. So we don't worry too much about like what Gartner and those sorts of people are saying, because the market, the people that we talk to, the people that are interested in technology and security aren't necessarily looking at it. But there's many other reasons why I think XDR is really good for organizations, because it will give them remediation, which is the key bit that people are after. But I've got 1 more minute, so if you want to give me a quick catch-up after, I'm pretty much done, and we can have a chat about it afterwards if you want to talk in more detail. So yeah, to try and wrap up with my last kind of minute to go, the key thing here really is about, for me, has always been about reducing your attack surface. If you're an organization that's got lots of complex systems, lots of stuff all around on the internet, or even internally, you're going to really struggle to protect those systems. It's just too big. There's too much of a problem to try and solve. So the more you can reduce the things you have to protect, the easier it is for you to be able to protect those systems and save yourself a lot of pain and hassle. I would always say trust but validate, because like I say, there's been lots of third-party suppliers that are being breached, and I know probably if a lot of you have been involved in any processes to sell to other organizations, there is way more due diligence happening nowadays. It's quite painful. It's really hard to go through the process, because also the people that are asking the questions generally don't know why they're asking you the security questions, and you've got to try and answer a question they don't really understand what they're asking. So making sure you're doing a good job of trusting that. And I think the last thing for me is just complexity is the enemy, and having that defense in depth is the way to secure and rescue your security. And that's really the critical way in which to make sure that you're staying ahead of the bad guys. But yeah, certainly think about what's out there on the internet, and do you really know what's exposed? Because like I say, a lot of the stuff I see, I'm just sure organizations have either used it to test or just forgotten that they've turned this feature on and it's now exposing everything to the internet. But anyway, that's it all from me. If you do want to find out more, we are actually exhibiting in the other areas. You can come have a chat to us. I talk a lot on LinkedIn about this sort of stuff. So if you're interested in cybersecurity, you want to find out more, you connect with me on LinkedIn. I don't sell things. I just talk about cybersecurity stuff. So if you want to find out more, then connect. It'd be lovely to connect with you guys and find out more. But thanks very much for sticking around and listening to my talk. I really appreciate it, and hope you have a good rest of your day. Thank you.